all, this is Miss Pierce here, and today we're going to be looking at our introduction into quadratic graphs, or as I also like to call them, parabolas, okay? And we're going to be talking about parabolas this entire unit, so really getting comfortable with a lot of the vocabulary is going to be part of our goal for today, okay? Also understanding that a quadratic function, sorry, just wanted to pin that, okay. So the parent quadratic function is just the equation f of x equals x squared. So when I say parent function, this is just like the most basic quadratic function that we could look at. And it looks like this guy, one of the most important features is probably the fact that the vertex goes through the origin, or it goes through the point 0, 0, okay? That's going to help us a lot when we're looking at these, especially because like when we shift them, it's going to help us to recognize like what the original function looks like. Noticing that it's always symmetrical on both sides is also going to be really helpful to us, and that it kind of goes up at this like really fast rate. And that has to do with the fact that like when we take a number and we square it, it becomes pretty fast, pretty quick. But we do see this sort of like pattern happening with our y values when we do that. Okay. So here are some properties of parabolas. One of the things we like to look at is also known as the concavity of them. That's just a fancy word for saying like, is it facing up? That's concave up. And if it's facing down, that's concave down. Okay. If the parabola does open up, then the vertex is called a minimum because it's at the bottom of the function. If the parabola opens down, then the vertex is called a maximum. And then, of course, we have the axis of symmetry, which is the line that goes through the middle of the parabola. So you can see here, that is this beautiful hot pink line that slices right through the vertex of this parabola. All right. So let's take a look at some examples. So we've got this graph here. This is the equation that goes along with the graph. So you'll notice that the vertex is this point right here, and that is the point -5, 9. Okay, and we're just going to state it like a point because the vertex is always a point. Okay, we can also call this the max or the min. So when we identify if the vertex is a max or a min, we look to see if it's at the top, it's a max. If it's at the bottom, then it's a min. Okay, so this is definitely going to be a maximum because it's at the top of our parabola. Okay, the axis of symmetry is going to be the invisible line that slices halfway, right? Symmetry, halfway. Okay, we always state it as an equation. It's always x equals -5 because it slices through the x-axis. All right. The roots and zeros, that's where the function is rooted into the x-axis. And we also state those as x equals -8 and x equals -2. Okay, they just have two names. So if I say roots or zeros, they just mean the same thing. And then, of course, we get back to our tried and true domain, which should be triggered x values. So the x values of this function exist, and then range being the y values. So the y values of this function exist. So we're going to start with the x values. Notice on the graph that we have these arrows, and actually, like you might think that it stops here at -10, but if you kept going, if you kept multiplying these x values and squaring them, they're actually going to keep going on and on forever. So the domain is -infinity to infinity. Your x values go on and on forever. However, with the y values, you'll notice that they stop, right? They have a maximum value. So the y values, they start at -infinity, right? Low to high. Okay. And the highest point is our maximum, which is 9. And 9 is included, so it gets a square bracket. Okay. The y-intercept It's a little tricky to see, so we're going to say that we can graph it in our calculator in order to do that. Actually, yeah, let's do that right now. Why don't you guys grab your calculators? Okay, and we can take that equation that we're given, which is this guy right here, and we can type that into our graphing calculator. So we're going to go, let's actually make this handheld. Okay, perfect. Even better. Okay, so we're going to go to the graph. No, graph. And we're going to type negative x plus 5 squared plus 9. Okay, this will give us some good calculator skills. So you can see here on your graph, you still can't see it. We're going to double click on that negative 6.67 at the bottom of our y's. And we're going to change that to, I don't know, let's say like negative 20. Okay, now we can see our y-intercept. So I'm going to go ahead and trace menu 5, graph trace, and it actually lands right at the y-intercept, which as you can see over here is at 0, negative 16. And we're going to state that just like a point. Okay. Get a nice, beautiful, different color. Let's do yellow for y-intercept, 0, negative 16. Okay. Now let's go to this one. So we're going to state the vertex again. Go ahead and try and do this while I'm doing it as well. So this is at 0, negative 9. Ooh, interesting vertex here. This vertex is a min because it's at the bottom of the function. The axis of symmetry, this is an interesting one. It goes right through the y-axis. So if you think about what this x value would be right here, it's 0, right? It goes right in between negative 1 and 1. So your axis of symmetry is at x equals 0. All right. Where your function is rooted, they're also called zeros because the y value is equal to 0. So x is equal to negative 3 and x is equal to positive 3. Okay? For your domain, all your x values exist. Again, it's going to keep going on forever and ever and ever. So from negative infinity to infinity. The y values of this function, however, they stop at negative 9. So the low is negative 9. The high is infinity. The 9's included. The infinity is not. All right. And last but not least, this y-intercept is nice and clear, except it's shared with the vertex. So it's actually the same point at 0, negative 9. So the vertex and the y-intercept are the same here. Okay? So again, just knowing the vocabulary is really going to be key. Being able to see any connections between these graphs and the equations is also going to be really helpful as we move throughout this unit. But just getting really comfortable with the vocabulary is going to help you as we explore quadratic functions more. All right. I hope you guys have a great day. Bye.